In this lesson, we complete part 4 of our functions series for Cambridge International AS Mathematics 9709 paper 12. The topics that we are going to cover is going to be translation, reflections, stretches, combined transformations, graph interpretation, and Cambridge exam style questions. If you understand transformations properly, graph questions become one of the easiest scoring areas in pure mathematics. The next lessons that we are going to cover in the function series will be Quadratics I and Quadratics II. Now, why does f of x minus 3 move a graph right through a translation vector 3, 0, even though the 3 is negative? If you have been memorizing transformation rules without really understanding them, this lesson will fix that forever, hopefully. We started this function series by learning what functions really are. So first we did the basics, then we did what composite functions were, and then we did the inverse functions, and today we study transformations. This is one of the most visual topics in the entire pure mathematics syllabus. Okay, so let's say y is some function y is equal to fx. Now, every transformation question begins with an original graph, let's say a simple parabola. Okay, or let me just draw y equals to x squared. I know this is not the best graph that I've drawn, but yeah, so something of this sort. Okay, so this is more like it. So y equals to x squared. Cambridge then modifies this graph or any graph that they give. Your job is going to be is to understand what modification happened. For example, if this graph moves here, or if this graph moves here and opens up like this, then you have to tell what modification happened in the algebra. So let's say that this is the original function, and let's proceed to do quite a few modification in order to make you understand what translations, what stretches, and what combined transformations are. So whenever we talk about translations, right? So whenever we talk about translation, make sure that we are just talking about movement. So the graph, if this is a graph, this just moves up, or it moves down, or it moves right, or it moves left, right? So this is just vector movements, right? So this is just movement. Okay, so if we are talking about vertical translation, that we are talking about whether if it's a line, then it's either moving up, or it's moving down, or it's moving right, or it's moving left, right? Now, if it is a parabola, for example, if it's a quadratic curve, then it's either moving to the left, or it's moving to the right, or it's going down, or it's moving up, or a combined transformation. So for example, if the translation vector is 3 comma 3 2, right? So this is 3. So, and if the parabola is like this, so it is moving 3 units to the right. So instead of vertex being at 0 0, this is going to be at 0 at 3 0, my bad. So this parabola moves at 3 0, right? And then it moves up by if the translation vector was 3 2, and then it moves up by 2 units. So our new vertex is going to be here. So this is a combined translation of vertical, which is this, and horizontal, which is this. Now let's see what does a vertical transformation do. Now, what happens if every y value of a function increases by 3? So let's say if there was a value, let's say if there was a value 0 comma 1, right? So if it increases by 3, right, the translation vector is 0 3. So every y value is increasing. So whatever, so this 0 comma 3, and let's say this is 1 comma 4, right? So 1 comma 4 becomes 1 comma 7, right? So 1 comma 7, this is going to come here. This point is going to go, so from 0 comma 1, it's going to go to 0 comma 4. So our curve is going to move up by 3 units everywhere, right? So this is 3 unit upward movement everywhere, right? So 2 comma 5 becomes 2 comma 8, right? So this is vertical translation, right? So only y values are changing. So we call this, so if the original function is y equal to fx, then the translated function is going to be f of x plus 3. Or if it's moving up or down by a units, then we will say that f of x plus a units. Now this a could be positive. In the case of positive, it's going to move up. If it's negative, then it is going to move down. Okay, now if a was positive and if this was f of x minus a, then you are taking away y values from the original, right? So now this means that this is going to be a downward movement. Okay, so translation will be downward. The graph or the function is going to move down because every y value is going to increase by a units. Okay, now the what students confuse all the time is whether f of x plus 3 is same as f of x plus 3, which is completely different. The left translation is in the y direction, the right translation is in the input direction, and while this is upward movement, this is leftward movement, and we'll talk about that why it is so. Okay, we'll move to that bit in a bit. Now, like I explained to you earlier in the vertical translations, the translations simply mean that the graph is not stretching, it's not opening up, or it's not getting compressed. It's simply movement. It's simply either going rightwards or leftwards or upwards or downwards. Okay, now in the case of horizontal translations, what happens is that if you have a parabola, let's say you have an original parabola here, so in horizontal translation either the graph is going to move here or it is going to move rightward, right? Maybe it may go like this, right? So now let's explore what happens in horizontal translations. Let's say you're given that an original function y equals to fx is now translated into or transformed into y equals to. Now transformation has types, so it has translations, it has reflections, it has stretches. So we are under transformation right now. We are doing translations, and we have already done vertical translations above in the previous section, and now we are on to horizontal translation. So let's say that you have f of x plus 3. Now what is happening is, let's say if you had an original point at 0, 0, now in order for you to get a 0, you need to make this. So this input originally of this function was 0, right? So x was 0. Now we are not going to put x as 0 here, rather we are going to make x plus 3 equal to 0. Therefore x has to become x minus 3. So what does that mean? That means that now our graph is going to move towards minus 3, 0. Do you understand why? That now when we take minus 3, then minus 3 added by a plus 3 is going to make the entire input a 0, and then it is going to produce the similar output 0 on y, right? So therefore whenever you have, and so let's say if this was your original function y equals to x square, and if you have to make a graph of now this was f of x. Now if you have to make a graph of f of x plus 3, therefore this is going to become x plus 3 whole square. So now this graph is going to move 3 units to the left at minus 3, and now we are going to draw this graph like this. Okay, so this, therefore x is going to be equal to negative 3. The point moved left, right? Now the rule is that and vice versa. So if f of x minus a means the graph moves right by a units, and if it is f of x plus a, then the graph moves left by a units. Okay, I hope this is clear. This is opposite to what students usually expect. They expect that if it is a negative a like this, then it must move to the left, and if it is a positive a, then it must move to the right, like in the case of vertical translation. However, this is not the case here, and I've just demonstrated through our graph here that why it is so. So there is a clear distinction between inside versus outside transformations, or in our case translations, right? So f of x plus a, which is, or I will write f of x plus a under inside, because this is inside, is definitely not equal to f of x plus a, and now this a is outside, this a was inside. These two are clearly not. So this one, they are clearly not similar, same, because this clearly is upward movement, and this is, sorry, my bad, this is upward movement if a is positive, upward movement or upward translation, and this is leftward movement or leftward translation. Okay, translation and movement is one and the same thing. This is where most marks are lost, right? So now we are going to move on to reflections. Now, what if you have to reflect your graph on basically if you have a graph like this, you have to move it, you have to reflect it on y equals to on the line y equals to 0 or the x-axis, right? Y equal to 0 line is this, which is just the x-axis. Let's say you have to reflect this on this line, which means that this point is going to come here, this point is going to go here, this point is going to go here. So basically it is going to get mirrored on y equals to 0 or x-axis. Now what has happened here? The x coordinate of this point is not really changing. However, the y, if this was a, now this becomes negative a. If this was b, then this point becomes negative b, right? So all my y values are changing. So if you have to reflect this y equal to fx on the x-axis, if you have to reflect it below the x-axis or vice versa, or above the x-axis in the case that for okay, so we will do that in a bit. So all you have to do is put a negative sign as a coefficient of the function, right? So if you had, so for example, if you had a function x squared minus 2x plus 3, let's say you had this function and you had to reflect this function below the x-axis, then all you have to do is you just put negative x squared minus 2x plus 3, because now all the output values, all the y values are going to change their signs. So this a is going to become negative a, this b right here is going to become negative b, this c right here is going to become minus c right here. Okay, so this is, so y equal to negative of fx is nothing but reflection in the y-axis, and it does not just make the positive values into negative, it also converts the negative values into positive. So for example, if your graph was something like this, then then all these values are going to become negative. 0 stays 0, this becomes negative, 0 becomes 0, and this part, this yellow part which was under the curve, which was negative, is now going to become positive. So the graph is going to get flipped completely. Okay, so this blue function is going to get, this is going to become the translated version, right? Sorry, transformed version, reflected version, right? So this is reflection in the, sorry, I wrote this wrong. This is reflection in the x-axis. Okay, now what happens if you have to reflect the function on y-axis? So for example, if you had a function like this and you have to reflect it on y-axis, which means that every value, so the y value stays the same, however the x value, this comes right here. So if this was a, this becomes negative a, if this was b, this becomes negative b, and likewise. So this graph gets translated, this gets mirrored here. So what is happening, all the x values are, so y values are being produced using a negative x value, right? So you are going to put, so y equals to fx gets transformed, gets mirrored on the y-axis if you take y equals to f of negative x. So for example, if your original function was y equals to x squared plus 2x minus 3, and you have to reflect it on the y-axis, then all you have to do is you, and this is f of x, then all you need to do is, I'll change color, this is, make this f of negative x. So this is going to become negative x squared plus 2 times negative x minus 3. So this is going to become x squared minus 2x minus 3, right? So this is going to translate the entire curve on the y-axis. Now mirror it on the y-axis. Now let's see a demonstration on Desmos here so that you guys can better understand it. Okay, right here. So I was telling you that if you have a function y equals to x squared plus 2x minus 3, let's say this, okay, so let's say I take it to be 5 and I make this plus 5, right? So now my function, okay, not plus 5, plus 8, right? So now, and let me make this negative. So my graph is like this. Now I have to see that this graph gets reflected on the y-axis, so it is going to flip horizontally to the other side, right? Now all I need to do is make the x values negative. So minus x squared is still going to become x squared. So this is going to stay the same, y equals to x squared. This minus 5x, when it gets x becomes negative x, so this becomes a plus 5x, so this becomes a plus 5x, and the plus 8 stays the same because there is no variable attached to it. So can you see how it has reflected on the y-axis? So y-axis is now acting as a mirror for these two functions, right? So this is what happens here. So this is about the reflection in the y-axis. So when the input changes sign, it is a reflection in the y-axis. If the entire function gets a different sign, so if the function was a negative function, for example, this could be a case, right, that the entire function is negative, this is below the x-axis, then if you multiply it by a negative, if you put a negative before it as a coefficient, the entire function is going to get flipped because all the output negative values are now going to become positive values for the same inputs, right? So this is the difference between them, and now we move on to stretches. Now, before I proceed, I want to tell you guys that only listening to or watching my lectures is not going to do any good unless you are complementing it by practicing through the Cambridge endorsed book, right? The P1 book that you guys have. And once you have done these chapters, then you do the relevant topical past paper questions, and you may access those from Papa Cambridge as well, right? They have compiled those questions in a topical manner very nicely. Now, let's do stretches. So I will again stress on the point that you have to complement your understanding by practicing the questions as well, right? I am doing a few examples here, but this is not all, right? Now, in stretches as well, there is a vertical stretch, which means that your graph, if it is like this gets stretched, this becomes here, and the graph goes like this. So this is a stretch. Or and we are going to see that for what type of coefficients does this or this may open up as well, right? So this is a less than one stretch, right? And we are going to see in a bit. And there are horizontal stretches as well. Now, in vertical stretches, let's say you had an original function y equals to 2x, right? Y equals to f of x, and if you have to transform it into y equals to twice of fx. Now you can totally see that what is happening here is that these are the output values, they are getting multiplied by 2. So 0, 1 is going to become 0, 2, 1, 3 is going to become 1, 6. So if you had a graph like this, so if this was y equal to f of x, now you will see that this, let's say this is 3, 1. So this is going to get translated into 3, 2, right? 3, 2. 1 becomes 2. If this point was, let's say 5, I don't know, let's say 5, 3. Let's say this point was 5, 3. So now at 5, this is the y value becomes doubled, right? So this becomes 6. So this point is going to get translated here, and now our new graph is going to go like this. So this is a stretch, right? Now, if this was a minus 2 f of x, now what has happened is first it has stretched, so now 2 of fx, and now we will put a negative sign. So all of these stretched values are going to become negative. So this value right here comes here, this value comes here, this comes here. So the stretched graph is now going to get flipped over and gets mirrored on the x-axis, because now it is a reflection on y-axis. So if y equals to negative 2 fx, so it does two things. First, it stretches every y value by a factor of 2, and then it mirrors the entire stretched graph on the x-axis. Hopefully that's clear. Now, there is another case as well. What if you have y equals to half of fx? Now, what does it do? So 0, 4 gets this coordinate becomes 0, 2. So now every value becomes half. So if this was like this, so if this point was 5, 4, so this is going to become 5, 2. So this value is going to come here. If this was 3, 2, so this is going to become 3, 1. So now the graph is going to get opened up. So do you see? So when the value is between so the stretch factor, so this coefficient is called the stretch factor. So when the stretch factor is less than 1, right, so when the stretch factor is less than 1 and greater than 0, that is, right, I'm not taking the negatives into consideration because that flips it over, because negative I will, so any negative sign with the stretch factor, I recommend that you deal it separately. So if it is a negative 0.8, so you first open it up by a stretch factor of 0.8. So let's say a y value was 10, so you multiply 10 by 0.8 to give you an 8. So your coordinate is going to come down from 10 to 8. Therefore the graph is going to get opened up, and since it was a negative 0.8, then you apply a negative sign and flip the graph over, right? So right now I'm talking about just the positive stretch factor. So this opens it up, and whenever the stretch factor is greater than 1 in the absolute terms, then this compresses, okay, sorry, this stretches it, right? So the graph becomes like this, right? If a graph is like this, and if the stretch factor is greater than 1, then this goes like this, and if the stretch factor is less than 1, then the graph opens up, okay? So now, so this was about vertical compression and vertical stretches. Stretches is greater than 1, compression is when it is between 0 and 1, and a negative value just flips it over. Now what happens in horizontal stretches? Now let's talk about horizontal stretches. Now you guys may think that I'm going too fast, but you guys can stop, and I would recommend that you open up the book while I am doing these making these explanations. So once you have listened to the section in this video for translation, you attempt the exercise in your Cambridge book for the translation, and then you move on to the vertical translation, horizontal translation, and then you move on to stretches and reflections, respectively. Okay, do not just consume this entire lecture and then try to do the end of chapter questions because you think that now you have seen the video, so you are know it all. Unless you guys are a retake student, then this lecture is going to serve as a refresher of your old concepts, and I'm assuming that you had already done those practice exercises in your book. Now in horizontal stretches, let's say you're given y equals to f of half x. Now what is happening here? X values double. Now if you had 1 comma 3, in order to obtain, now this was in the original function y equals to fx. Now when the input was 1, you were getting the output that was being produced was 3. Now in order to get the same output, you have to take twice the input. So you have to put x is equal to 2 here in order to get, so when I put x is equal to 2 here, 2 multiplied by half is going to give me an input of 1, and then it's going to produce me an output of 3, right? So if this was 1 comma 3, if this point was here, now when the stretch factor is half, now the graph is going to come here. So this point is going to come here. If I had another point was at 0, okay, so if there was another point at, let's say, 3 comma 5, if the point was right here, now in order to get the same output of 5, I need to take a value of 6, because 6 is going to get halved here in order to give me a 3. So a 3 comma 5 is going to get transformed into 6 comma 5 because of this stretch factor, right? So every input value is divided by the horizontal stretch factor, right? Every x value doubles. However, if the stretch factor was y equals to f of 6x, now you are going, in order to get the same output value, you are going to take an input value of 1/6. So now every input value becomes 1 upon 6. So you always divide by the stretch factor whenever you are dealing with the horizontal stretches, right? So the rule is that if y equals to the transformed or the horizontally stretched transformation of a function is y equals to f of kx, then the horizontal factor is going to be 1 upon k. If k is, let's say, is a fraction, let's say it is 2 upon 3, then you put 1 upon 2 upon 3 so that it becomes a factor of 3.2. So every input value gets multiplied by 1.5, and this concept is heavily tested. Now we will now move on to combined transformations. Now, Cambridge doesn't test you usually isolated transformations. Like it's not going to just ask you a question on reflection or isolated question on a stretch or an isolated question on, let's say, translation or reflection. However, what it does, it is going to, let's say you have a function y equals to fx, then Cambridge is going to give you y equals to 2 of x minus 3 whole square plus 1. Now, what has happened here, right? Students may correctly identify that it's a rightward movement. So this is a rightward movement. So I will call it horizontal by 3 units, right? And then this is a stretch, vertical stretch of 2, right? Rather, it is not a vertical stretch of 2, because what has happened here, so this is y equals to 2 times x minus 3 whole square plus half plus yeah. So no, sorry, my bad. So this is sorry. So this is a vertical stretch of 2, and this is a positive upward movement by 1. So this is a horizontal translation of 3 units to the right and a vertical translation of 1 unit up, and then a vertical stretch of 2 units, right? Now, the order is that you do the inside first and then you do the outside after that, right? So first there is going to be this, and then you are going to do this stretch factor, right? So if this was y equals to fx, so the first translation was y equals to f of x minus 3, right? So basically if y was, or so if f of x equal to x squared, then f of x minus 3 is first, which is x minus 3 whole squared. Then you multiply the function by x minus 3. So this is a vertical stretch of 2 units after the horizontal translation of rightward movement to 3 units. And then you add 2 of f of 2 times f of x minus 3. Sorry, there is no square, plus 1. So now this becomes 2 times x minus 3 whole square plus 1. So now this is so this was original. This was rightward movement by 3 units. This was vertical stretch factor is equal to plus 2, right? And then this is vertical translation of 1 unit up. So this is 0 1 and this was 3 0, right? So this is the order that you really need to do in. Now, let's say if you have g of x equal to 2 times x minus 2 whole square plus 6. Now, how would this have been obtained by an original function of f of x equal to x square? You guys should pause the video, try to do it yourself, try to list the order, and then check and then resume the video and see if you have done it correctly. Now I'm going to proceed to solve it. Now this is what? This is, first of all, this was f of x minus 2. So this becomes x minus 2 whole square. Then this was 2 times x minus 2. So this becomes 2 times x minus 2 whole square. And then this was 2 of fx minus 2 plus 6. So this becomes 2x minus 2 whole square plus 6. So first of all, this is a horizontal translation of positive 2 units. And then this is a vertical stretch and a stretch factor. I'm just using the acronyms. A stretch factor of positive 2. And then this is a vertical translation by 6 units. So this is translation vector is 0 6, right? So this is the full transformation sequence here. Now the examiner traps are that you do the left and right side reversed. So instead of, if you are given y equals to fx plus 3, then instead y equals to f of x plus 3, then instead of moving units 3 units to the left and making the translation vector minus 3 0, you would do plus 3 0 and you will lose all the marks. Trap number 2 is always that whenever you are given so whenever it says that you have to reflect, so if they say that the y equals to minus f of x, then you translate on the y-axis, making all the input values negative, which is wrong. These are, so this minus sign is making the output values negative, right? So this is the reflection on the x-axis. On the x-axis, this is making the output values negative, right? So students, more often than not, they confuse x-axis reflection with y-axis reflection, right? Now in horizontal stretch factor, if this is y equals to 1 up f of 1 upon 3x, then all the input values are going to be multiplied by stretch factor 3, which is 1 upon k. If, like I told you earlier, that if the stretch factor if k is k, then the input values gets multiplied by 1 upon k, right? And then the last thing that is very important is that students usually mess up in the transformation order. Like if this is y equals to x minus 4 whole square, and one more thing. So if this is 2x minus 4 whole square times 8 plus 6, then if this was transformed from y equals to x squared, then what happened first of all, this became, so this was, let's say, f of x. So first of all, what happened was this became f of x minus 2. So this is x minus 2 whole square, right? And then, sorry, my bad. So first of all, this was f of 2x. So this became 2x whole square. And then what happened? So this is 4 of x, right? Sorry. And then it was 2x minus 4, right? Or you would do x minus 4, x minus 2, right? So now this became 2x minus 2 whole square. Okay, so and actually this is 1. Okay, so this is x minus 1. So now you put a minus 1 here. So so this became, okay, so there is a slight confusion here. So I will make this into, so first of all, let's deal with it. So this is actually 4 times x minus 1 whole square. So this is nothing but 8 times 16 and then x minus 1 whole square plus 6. So you will first rewrite it as 16 times 8, whatever that is, 128 times x minus 1 whole square plus 6. So this makes your life easier. So now if it gets transformed from y equals to x squared, all you can simply do is you first make this into x minus 1. So this becomes x minus 1 whole square. Then you do 128 f of x minus 1. So there's a vertical stretch factor of 128 x minus 1 whole square. And then you add a plus 6 to it. So this is going to be 128 f of x minus 1 plus 6. So this becomes 128 times x minus 1 whole square plus 6, which is the same as this one. Okay, so there was a small confusion which a lot of students also gets confused into. So today we learned how graphs move, right? Whether they move to the right, whether they move to the left, whether they gets vertically translated upward or vertically translated downward, or they gets reflected on the y-axis, or they gets reflected on the x-axis. On the x-axis, or they gets reflected on the y-axis. Right? In the next lesson, we'll begin Quadratics I, and then after that, we'll be doing Quadratics II and the quadratic formula, and what does how we interpret the minimum and maximum curves, how to find the roots and everything around that, right? So you'll discover something interesting, that quadratics are really just transformations of y equals to x squared, which we did here. So I hope that before you come to my next lesson on Wednesday, you would have already revised those exercises from your P1 book, so that you are ready to grasp the new concept of quadratics. So this lecture is a strong bridge into your next lecture. Now, If you have any queries, you can, just like I always tell you, you can WhatsApp me directly on +92 329 3028 485. Or if you want to stay updated on whatever is happening on our channels, you can reach out to us on our Instagram, where we go by the name of Easy, EASYTALEEM. Until then, I wish you good luck.